Dear students, today we are performing the experiment to verify the laws of series and parallel combination of resistances using MeterBridge. Now the apparatus required in this experiment, first that is the MeterBridge, then battery eliminator, resistance box, rheostat, galvanometer and two known resistances as well as a jockey key and some wires to connect the circuit. Now first draw the circuit for the series combination of resistances as you see here. Then draw this second circuit for the parallel combination of resistances as you see here. Now connect the circuit as you see here. First, connect one terminal of the wire of MeterBridge with the positive terminal of battery eliminator, then negative terminal of battery eliminator that is connected with the lower terminal of rheostat, and then upper terminal of rheostat is connected with other terminal of the wire of MeterBridge. Connect resistance box in one gap of the MeterBridge as you see. Now connect the series combination of two known resistances in another gap as you see. Here connect one terminal of the gap with one terminal of resistance. Then the second terminal of resistance is connected with one terminal of another resistance, and then another terminal of the second resistance is connected with another terminal of the gap. Now connect one terminal of the galvanometer at the central terminal of the MeterBridge and another terminal of galvanometer that is with jockey key. Now we have to perform this experiment exactly like we performed to find out the resistance and resistivity using MeterBridge. Now switch on the circuit and then after first adjust the rheostat such that here in galvanometer you obtain the deflection on both the side when we touch the jockey key on either side of the wire. Now adjust a particular value of the resistance in resistance box, and then after using jockey key obtain the null point in the galvanometer as you see. See, your galvanometer is showing the zero deflection, and for that now measure the length of the wire. Now repeat the experiment for 4 more values of resistances in this resistance box, and for each one find out the null point and measure the length of the wire for that null point. Now prepare the parallel combination of resistances in the gap of the Western bridge as you see here. First, connect two terminal of the gap directly to the two terminal of one resistance, and then connect those two terminals of the resistance directly with another two terminal of second resistances. Now repeat the experiment as we performed for the series combination of resistances. For 5 different values of resistances in resistance box, find out the null point on the wire of the MeterBridge for each one. Then note down all the observations in the observation table. Now prepare the observation table as you see here. In our case, the known resistances R1 and R2 are given 8 ohm and 12 ohm respectively. Now first take the observations for the series combination of R1 and R2. Now in our experiment for series combination of R1 and R2, when the value of the resistance in resistance box adjusted 15 ohm, the null point is obtained at 56 centimeter on the wire of meter bridge. Therefore, L dash equal to 100 minus L, that is 100 minus 56, that is 44 centimeter. Now take 4 more observations for different values of resistances in resistance box. Now the observations for the parallel combination of resistance R1 and R2. For the value of the resistance 5 ohm in the resistance box, the null point is obtained at 46 centimeter on the wire of meter bridge for parallel combination of R1 and R2 in our case. So L dash equal to 100 minus L, that is 100 minus 46, that comes to 54 centimeter. Now take 4 more observations for different values of resistances adjusted in resistance box. Now using these observations and the given equation, calculate the effective resistance in series and parallel combination. Now in our experiment, for the observation taken here for series combination of resistance R1 and R2, the effective resistance Rs equal to R into L upon L dash, that is equal to 15 into 56 upon 44. It comes to 19.09 ohm. Similarly, calculate the effective resistance for series combination of resistance R1 and R2 for 4 more observations. Then calculate the mean resistance for the series combination of R1 and R2 resistance. Then compare the experimentally obtained value of series combination of R1 and R2 with theoretical value of series combination of R1 and R2, that is Rs equal to R1 plus R2, that is equal to 8 plus 12 equal to 20 ohm. Now effective resistance in parallel combination of R1 and R2, that is Rp equal to R into L upon L dash. So for our observation, it comes to 5 into 46 upon 54, that is equal to 4.25 ohm. Similarly, calculate the effective resistance of parallel combination of resistance R1 and R2 for 4 more observations. Then after, calculate the mean resistance for the parallel combination of resistance R1 and R2 using this equation. Now compare it with the theoretical value of the parallel combination of resistances R1 and R2, that is Rp equal to R1 R2 upon R1 plus R2, that is equal to 8 into 12 upon 8 plus 12, and that comes to 4.8 ohm. Now calculate the error arising in the measurement of the series combination of resistances R1 and R2 using the equation delta Rs equal to Rs into delta L by L plus delta L dash by L dash. Now calculate this error for all 5 observations and then find the maximum value of delta Rs. Now calculate an error arising in the measurement of parallel combination of resistances R1 and R2 using the equation delta Rp equal to Rp into delta L by L plus delta L dash by L. Calculate error arising in the measurement of parallel connection of R1 and R2 for all 5 observations. Then take the maximum possible error arising in the measurement of parallel combination. Now, note down your results in this table with the theoretical values as well as your measured value with maximum possible errors.